I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see one example problem and how we are going to solve by using k-means clustering algorithm. In the previous lecture, we have seen the detailed discussion about k-means clustering algorithm. We'll solve one problem by using k-means clustering algorithm. We'll see the example problem. Here consider 5 points x1, x2, x3, x4, x5 with the following coordinates as a two-dimensional sample for clustering. x1 is 0.5, 1.75, x2 is 1, 2, x3 is 1.75, 0.25, x4 is 4.4, 1, and xy is 6, 3. Illustrate the k-mean algorithm on the above data set. The required number of clusters is 2. And the initially clusters are formed from the random distributions of samples. So we are going to consider C1 is consist of the samples x1, x2, and x4, and C2, the cluster C2 consists of x3 and x5. And we'll solve the problem. And this data points, then the problem consists of 5 data points. The all 5 data points are the 2D space. X1 is this value, x2, x3, x4, and x5. And initial clusters in the given the problems are C1 is equal to x1, x2, x4, C2 is x3 and x5. And the initial centroids, randomly we can choose it x1 from this C1 cluster. We'll take one centroid. X1 is equal to 0.5, 1.75, and from C2 we'll select one more centroid 6, 3, 6, 3. X5 we will consider. And by using the Euclidean distance, we have to calculate the distances. How we are going to calculate the distance in the sense? So we are going to calculate the distance in terms of by using the that is Euclidean distance. Calculate the Euclidean distances to centroids. D is equal to root of x2 minus x1 the whole square plus y2 minus y1 whole square. This is the distance calculation by considering the Euclidean distance. And how many points we have given? How many samples we have given? 5 samples: x1, x2, x3, x4, x5. And the values are 0.50, 1.75, 1 to 1, 2, 1.75, 0.25, 4, 1, 6, 3. This we have given in the second column. And we have to calculate the Euclidean distance by using this formula D of for the cluster C1. So cluster C1 we have randomly chosen the centroid 0.5, 1.75. So if you are substituting 0. Here x2 0.5 minus 0.5 is equal to what? 0 minus 0 the whole square 0, and 1.75 minus 1.75. So 1.75 minus 1.5 the whole square is 0 square 0. So what is the distance for this first coordinate? The first value 0.00. And if you are considering the cluster 2, what is the value we have taken? We have taken 6, 3. So in the 6, 3, if you are subtracting 6 minus 0.5 is 5.5. 5.5 is the square plus of 3 minus 1.75 the square. So if you are subtracting and both the squaring, taking the squares, both the cases, and adding and taking the square root, we are getting 5.64. And comparing these two values, we have to take, this is the minimum nearest value. So we have to consider 0.00. So what is the cluster we have to choose? The assigned cluster is C1. And for the similarly for the point x2, we are calculating 0.5, that is 0.5 minus 1 is 1.5 the square, and here 1.75 minus, or otherwise 2 minus 1.75 whole square, 0.25 whole square, and here the 1.5 the whole square, and taking the square root, we are getting the value 0.56. Similarly for 6, 3, 6 minus 1 is 5 square, 25 plus 3 minus 2 1 square. So 25 plus 126, if you are taking the square root, you are getting 5.1. And comparing these two values, we have to select this 0.56 C1 cluster. Similarly, X3, we are getting this value is 1.95. Here 5.6. So which one is less value is 1.95. So the cluster C1 we have to consider assigned cluster for this X3 sample is C1 and 4, 1. If you are taking for this the same formula we have to apply, and if you are applying we are getting 3.58 and 2.x3. The cluster what we have considered is C2, right? Here this is the smallest integer, and 6 comma 3 5 comma that is for this we are getting 5.64, same thing. And 6 comma 3 6 comma 3 we have to, that is we are getting 0 value. The chosen assigned cluster is C2 we have to choose it. So the new clusters after step 1, what is the updated clusters? By considering this table, the updated clusters are C1, C1, C1. So we have to consider X1, X2, X3. For C2, X4 and X5. C1 is equal to X1, X2, X3. So this we are calling it as the cluster calculation. Cluster after step 1. This we are calling it as the updated clusters. And step 2, what it says, the recalculate the centroids. Again, we have to recalculate the centroids. And then we have to again one more time we have to apply it, and we have to check the same clusters or same samples are being taken. So for C1, what are the points we have to consider? X1, X2, X3. So here, because initially we have taken in this case X1, X2, X4, X3, X5. After applying the centroid, we got C1, C1. This for X1, X2, X3. For C2, X4 and X5. So C1, X1, X2, X3, the new centroid, recalculate the centroids. X bar is equal to, if you have to add all the values, X1, X2, X3 value, 0.5 plus 1, 1.75, and another value 1.75 to 0.5. So if you're calculating X bar, you are divided by 3, a centroid, average we have to take. 1.08, 1.33. The new centroid for C1 is 1.08, 1.33, and C2, X4, X5. What is the value for X4? 4 plus 6 and 1 plus 3. If you are calculating, you are getting divided by 2. I got two values. We are getting 5. 4 plus 6, 4 plus 6 is 10. 10 divided by 2 is equal to 5. Here 4 divided by 2, 2. And new centroid C2 is equal to 5, 2. Here for C1, 1.08, 1.33. And if you are using the same value, and as like what we did it in this step 1, the same type of calculation we have to do, but we have to consider the new centroids 1.08, 1.33, and C2 we have to consider 5, 2. If you are considering this, and the same formula, if you are applying x2 minus x1 the whole square plus y2 minus y1 the whole square root of the value calculating, you are getting for this x1, x2, x3, the samples you are getting. For this column, 0.72 is minimum, so we have to select C1. And here, comparing these two, 0.67, we have to consider C1 cluster. We have to take, and in these two cases, 1.727 we have to select C1. And here, which one is minimum? 1.41, 1.41. So C2, C2. So from this calculation, in the previous case also, we got C1 for x1, x2, x3, C2 for x4 and x5. Similarly, in this case also, in this step also, after recomputing the distances by using the new centroids, in this case also C1, C2, C1, that is C1 for x1, x2, x3, and the cluster has been selected for x4, C2 is selected for x4 and x5. From this table, we are coming to the conclusion that the clusters remain same for the previous case and also the second iteration. So in the so after seeing this, we are coming into the conclusion that convergence is achieved because clusters remain the same. So the final clusters are unchanged. and convergence is reached. We have to write the conclusion like this. Final cluster C1 nor C1 is equal to x1, x2, x3. Centroid is 1.08, 1.33, and final cluster C2 is x4, x5. The centroid is 5, 2. Hope all you understood about this concept. So the final result summary we have to write like cluster C1, C2. What is the point? We have to take samples x1, x2, x3 for C2, x4, x5. The final centroid for SC1 is 1.08, 1.33, and for centroid 2, C cluster C2, x4, x5 points we have to consider. The final centroid value is 5, 2. And from this, by making use of this answer, we can able to draw the graph. We have to, by using the cluster values, we can able to draw the graph. In this case, there are 5 2D points, x1, x2, x3, x4, and they are spread across 2D plane. There are two clusters. Cluster 1. This cluster 1 is the blue. It contains x1, 0, what is the value for x1? 0 0.5, 0 0.5, 1.75, x2, 1, 2, 1.75, 2.5. So this value we are marking over here in this. X4 is 4, and cluster 2, this blue line is cluster 1, green line is cluster 2, and it contains x4 and x5, 4, 1. See here 4, 1, and the another value is 6, 3. So we have marked it. This what are this big cross mark says that it is the centroid. So the large X marks here, blue and green, X marks represents the final centroids after convergence. What is the value you got after convergence? 1.08, 1,33, 1, the comma 1.33, and for C2 5, 2. So this only we have 5, 2, and this the previous one what we have seen 1.08, 1.08, 1.33 we have marked it. So centroid 1 is the blue X, and centroid 2 is the green X, 5, 2. And cluster formation, we are looking into in this. Each point is assigned to the nearest centroid using the Euclidean distance. After 2 updates, the clusters no longer change, meaning the algorithm is convergent. Algorithm is converged. And why this graph is important? This plot visually confirms that points are grouped based on similarity. That means what? Distance. Final clusters are stable and centroids are accurately representing each group. So that only the graphs are very, very important. And the k-means process, how it continues, we have to start the process, initialize the centroids, and then assign each point to the nearest centroid, recalculate the centroids, and repeat until no change. In our case, 2 times, 2 iterations we have done it. And once if we are achieving the final cluster converge, that we are calling it as the final clusters. And another one more thing you should understand how centroids affects the clustering. So first point is the centroids are the heart of k-mean. How we are saying this? Centroids are heart of the k-mean. Centroids are the central element in the k-mean algorithm. The represents the average position of all the data points assigned to a cluster. Each centroid acts as a prototype of its cluster, and the quality of clustering heavily depends on how accurately the centroids reflect the actual distribution of data. The entire clustering process revolves around adjusting these centroids to minimize the distance between data points and the nearest cluster center. And the second, how it affects distance from centroid decides which cluster a point joins. How we are saying in each iteration of k means every data point is assigned to the cluster whose centroid is closest to it based on Euclidean distance. This step is crucial because it determines the initial structure of the clusters. If a point is closer to one centroid than another, it becomes part of that centroid's cluster. This rule ensures that each point is grouped with others that are most similar in terms of position in the feature space. And the third point is initial centroids influences how clusters form. That is, poor initial choice can lead to poor result. How we are saying? The initial placement of centroids can greatly influence the final outcome of the algorithm. That we have seen it. If the starting centroids are poorly chosen, the algorithm may converge to a suboptimal solution where the clusters do not represent the natural structure in the data. This sensitivity to initial conditions is why methods like k-means have been developed to improve the k-means algorithm, to improve the selection of starting centroids and reduce the risk of poor clustering. And the fourth point is recalculated centroids shift the cluster boundaries, pulling or pushing points into different groups. After each round of assigning points to the nearest centroid, the centroids are recalculated as the mean of the points in each cluster. This repositioning can shift the cluster boundaries, causing some points to move a different cluster in the next iteration. The recalculation step ensures that the centroids adapt to the data, leading to more coherent and accurate grouping over time. And the final point is convergence happens when centroids stop changing. This means what? Stable cluster. The k-mean algorithm continues iterating between assignment and centroid update steps until the centroids no longer change significantly. This state is called convergence and it indicates that the clusters have stabilized. And at this point, each point is assigned to its most appropriate cluster, and the centroids accurately reflect the center of those groups. Convergence ensures that algorithm has found a relatively optimal partitioning of the data. So in this way, the centroids affect the clustering. This is very, very important point we have to consider while you are studying the k-means algorithm. Hope everyone understood this problem very clearly. The remaining things we'll discuss in the next lecture. Thank you.